Okay, this online event is designed for teachers who are new to delivering the International GCSE Physics spec. The training is comprised of 3 standalone modules, which are booked separately. And this module, number 2, will hopefully give you an understanding of how the content is assessed by reviewing the assessment objectives and the mark schemes, have a little practice of applying the mark schemes using some exemplar student work, as well as an understanding of how marks were determined. You might have come to this Welcome to Pearson course for a number of reasons. It may be because your school has suddenly switched specifications and you're starting with the Pearson Edexcel specification now. You yourself might have switched schools to a school which uses that spec, or you might be new to teaching yourself. Whichever your case, very welcome to this session. My name's Keith Penn, and I've been a physics teacher, physics to A level and science to all sciences to GCSE for 33 years in London and the southeast, East Anglia, southeast of the UK. And currently I'm working as a lead science trainer for Pearson Edexcel, which is why I'm joining you today. I'm joining you from just outside Cambridge in the east of England, and it's a very, very wet spring morning. I hope you are getting better weather than I am. Let's get on with it. Okay, in this training, you'll hopefully understand the assessment objectives for the qualification, understand the question types and the mark schemes, have a little practice of using the mark schemes using some exemplar work to look at the way in which practical skills are assessed, consider exam technique and time management in an exam, and also learn a little bit about the support provided by Pearson around assessment and exemplars. As I mentioned, I assume that most people attending this session were here for yesterday's module 1 because it comes as a package, as it were. So I'll just start with a quick recap of the specification and the different assessment routes open to you. And I am aware that this is a recap of material I shared yesterday. We're the world's leading learning company and as the UK's largest awarding organisation, best placed to provide qualifications aligned to the British educational system. Our heritage stretches back over 150 years. And today we partner with schools, universities and employers worldwide, offering world-class recognised qualifications to over 3.5 million students a year. We're a partner to 6,500 schools, colleges and employers across the world and mark over 10 million exam scripts on behalf of the UK Department for Education each year. We currently operate in 70 countries worldwide. As I mentioned yesterday, there are 2 different routes of assessment, the linear course, which has been in place for about 5 years now, and the modular route, which is just being introduced at the moment. If you're happy with the linear approach, there's no pressure to move on to the modular route. The linear GCSEs will continue to be offered and taken widely by students around the world. But in the new modular route, which is being offered by Pearson Edexcel for the first time at International GCSE, unit assessments can be taken over multiple exam series. Grades are calculated on raw marks, which are then converted to a uniform mark scale. Students can resit individual units in any exam series. Yesterday, I was asked a question, and I do apologise, I can't remember who asked the question, but I was asked the question, how long those last for? Is there a sort of sell-by date on those? And the answer is no. I checked upon with the board, and there's no time limit on that, so you can take the second module at any distance after the first. Those carry on, which is good news. The linear route.
Thank you, Keith. Thank you. It was me who asked the question, and so this means that the student can complete this modular in 4 or 5, or can hold on to it for as long as they want. There's no limit.
At the moment, that's exactly what it says. Yes, yes.
Okay, thank you.
Which surprised me too, but you're absolutely, but it's good news. I think it makes it more flexible. And the linear route.
Thank you.
As before, assessments for all units taken together in one exam series, and the grades are calculated on raw marks only. Students can resit assessments for all units together in one exam series, and the grades students receive are calculated at the end of the series in which they sat their assessments. So if you believe the modular route will be of benefit to your students and could help you perhaps attract different families to your school, we can support you in moving to this route for your selection of subjects. So do contact your regional representative or the science advisor, Irene, and to see how to go about that. The modular and the linear approach contain the same content, but the modular approach breaks the journey into 2 units with an exam at the end of each unit. If you're already offering Pearson Edexcel International Linear GCSE, this will continue to be offered and remain exactly as it is. So students taking the linear approach will have studied all the content before the exam. So the linear specification is structured in a way where all topics can be assessed in both exam papers. So as you can see here, this is looking at paper 1, and looking down the linear route, there's a 2-hour exam, and it looks at topics, all 8 topics: forces of motion, electricity, waves, energy resources and energy transfer, solids, liquids and gases, magnetism and electromagnetism, radioactivity and particles, and astrophysics. Whereas if you compare that with paper 1 of the modular, it looks at 4 of the topics 1, 2, 4 and 5 as listed there in that first modular paper. If we look on paper 2 for both routes, the linear second paper is slightly shorter, 1 hour 50 minutes, and this time it assesses all the content. So the content which is in the combined science physics element, but also that which is in bold and has a C prefix, in other words, is just for students doing the single science physics. And again, questions may come from any one of those 8 topic areas that I mentioned just a moment ago. And bold statements in that specification cover some topics in greater depth. Paper 2 for the modular looks at the topics listed there. So topic 3, waves, 4 and 5 as appear in both papers, and then topics 6, 7 and 8 in paper 2. Okay, so both modular papers, 1 hour 40 minutes, and as we just discussed, they can be taken at any time. You can choose when students are ready, and they can be retaken too. Exams on both routes contain a mixture of different question styles, including multiple choice questions, short answer questions, calculations, and extended open response questions. And I'll be looking at what those types of questions are in a moment. And a calculator says here may be used in the examinations. As I said yesterday, I would say as a physics teacher, a calculator must be used. And please encourage your students to get used to using the calculator they're going to use in the exam during the course. I know more and more students, as all of us do, have a scientific calculator on our mobile phone, and students sometimes get into the bad habit of using that because it's convenient, they've got it with them. But it means they turn up for the exam, they can't use their mobile phone there for obvious reasons, and so suddenly they're using a scientific calculator that they haven't used before. And that's the very worst time to learn how to use the calculator. So please get your students used to using their scientific calculator through the course that they're going to be using in the exam. I see a couple of people have just entered the waiting room. Are you admitting those, Lloyd, please?
Yep.
Yeah, great. Thank you. Thank you. Teaching in a modular way. These are being worked on currently, and as soon as they're available, they'll be uploaded to the relevant qualifications website. As you can see on screen, there's a suggestion you might want to change the way you teach the International GCSE chemistry spec if you take the modular route for assessment. And to support your planning and teaching the course, we're producing, as we already do for the linear course planners, editable schemes of work and getting started guides. First teaching for the IGCSE Physics modular is this coming September 2024, which means the first assessment will be next summer, May or June 2025. You're getting in at the first open door. And resits for modular international GCSE, learners can resit any unit irrespective of whether that qualification is to be cashed in. If a learner resits a unit more than once, only the better of the 2 most recent attempts of that unit will be available for aggregation to a qualification grade. So they can't keep sitting and just pick the best one ever. It's the best one of the most recent 2. Results of units will be held in the unit bank for as many years as this specification remains available. So the only rider to the answer I gave to Junaid a moment ago is that as long as that specification remains viable, students can take the second module or maintain their scores for that period of time. Once the International GCSE in Chemistry modular has been certificated, all unit results are deemed to be used up at that level, and these results can't be used again towards a further award of the same qualification at the same level. And for more details, as I say, look in the specification and talk to the regional rep. If you have any questions on this, please do refer them to your, do talk to your local Pearson representative, or contact Irene, whose contact details I'll share with you again later in this session. Okay, we're going to look now in more detail at the assessment objectives and the types of question that are used in our exams. What are the assessment objectives? There are three of them. AO1, 2, 3 stand for Assessment Objective 1, Assessment Objective 2, and so on. Assessment Objective 1 is knowledge and understanding of physics, and around 40% of the questions will be on Assessment Objective 1. It's recall of content. Assessment Objective 2, application of knowledge and understanding, analysis and evaluation of physics. And again, about 40% of the marks are on questions looking at that assessment objective. Assessment Objective 3, specifically aimed at experimental skills, analysis and evaluation of data and methods in physics. So primarily aimed at assessing students' learning from their work in core practicals and other practical activities, experimental work, and that accounts for around 20% of the total marks, adding up to the total of 100% there. If we look at how they relate to the units, you can see there's a slightly different breakdown in paper 1 and paper 2. This is for the linear course, okay, and you can see, and that reflects the fact that paper 2 in the linear course addresses all of the content, including that which is for students only doing single science physics, as opposed to those doing the double balance science. Okay, what types of questions?
Keith, Keith, I have a question here.
Yeah, sure.
If you could please go back to the previous slide.
That one?
Yes, please. No, this one, the one with paper description and relating it to the assessment objectives.
Yeah.
I'm sorry, but I am not a little clear. Could you explain that how, like, for example, in paper 1, 23.2 to 25.7% of assessment objective 1 is tested, and the same objective has a percentage of 14.8 to 16.3 in paper 2. Am I correct?
Yes, that's right. Yes. And
it
reflects the fact that in paper 2, in the linear course, this is paper 2 includes assessment of all the content, whilst paper 1 only assesses the content which is common to both separate physics and the physics element of double award science. So that's why the weightings are slightly different, because if you remember looking at the overall weighting, if I go back yet another slide, Assessment Objective 3 only accounts for between 19 and 21% of the total marks, whereas 1 and 2 are around 40% between them. So it's split slightly different between the two papers to reflect that fact that paper 2 is including assessment of all the content. Okay.
Right. Thank you so much. Thank you.
No problem. Okay, the 4 categories of question, both papers include a mix, and all the papers for the modular too will include a mixture of different question styles, including multiple choice questions, short answer questions, calculations, and the longer extended open response questions. And I'm going to look at an example of each of these, just to give an example of the way in which those questions are asked. They won't be that unfamiliar to you, I'm absolutely sure. Here's an example from a paper 1 of a multiple choice question. As you can see, the question is about waves. Which of these waves is longitudinal? And then students have to select one of the options A, B, C, or D: infrared, radio, sound, or ultraviolet. It's worth emphasizing to students that there's no penalty for a wrong answer. So students sometimes think they start with a pile of marks and then each time they make a mistake, they sort of get marks knocked off. That's not the way it works. There's absolutely no penalty for having a wrong answer. Clearly they don't get a mark for it, but they don't lose any marks. So there's no advantage at all in leaving an answer blank. If a student really has no clue about the question, a guess is going to give them 25% of a chance of getting the right answer. they might be able to improve their odds on that by saying, well, I know it can't be a C and D, you know, so I'm choosing, you know, so they can improve their odds. So please encourage students not to leave them blank. If they get to the end and they've got a few that they couldn't answer, it's worth just putting crosses in. There's nothing to lose on that front. Short answer questions. Here's an example of a short answer question from paper 1. This one is about food preservation. The diagram shows how gamma radiation is used to irradiate food stored in a wooden box. The radiation kills bacteria on the fruit. You can see there's a gamma source in the simple diagram and a wooden box containing the food. Explain why gamma radiation is used instead of alpha radiation to kill bacteria. I'd set you a little challenge. I almost guarantee that if you go into a class of GCSE students and show them this question and ask them what do they think is the most important word in the question, a significant number of students will say radiation. It's about radiation. They might say gamma, they might say alpha. A significant number will say the most important word in the question is radiation. No, 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 no. The most important word in the question is the command word, which in this case is explain. It says explain why gamma radiation is used. And it's because the command word tells students what it is they're asked to do. It's heartbreaking when you look at students' attempts at questions and they've seen a question such as this, they've homed in on the word radiation and said something about radiation. And it might be entirely accurate, it might be true, but if it isn't answering the question that's being asked, they won't get the marks for it. The command word is absolutely key to answering the question that's being asked. And so often students lose some or all of the marks, not because they didn't know the answer, but because they haven't answered the question that was asked, or they have answered a question that they wish had been asked, but wasn't, you know. So please get students used to picking out the command word and thinking, what is it I'm being asked to do here? An explain question, as you know, the explain word means they got to say what's happening and then why is it happening? They need to explain. So an explain answer to get the full 2 marks that are available needs to have a word like because in it, or something that means because. This happens because such and such. So they need to, that's why you can see in the grayed out number to the bottom right hand corner where it says 2, there are 2 marks available for it, and one of those marks is the explain part of that. So please get students used to picking out the command words. I get them to underline the command word before they tackle the question to remind them that this is the important bit of the question. I'll come back to command words. I'm sure it's a song I shall be singing many times. I hear myself coming back. Okay, this is a calculation question. This is an example. Part 2, the bottom part, is an example of a calculation part question, again from paper 1. The full question has several parts, but we just picked out this part as an example. And you can see there's a table of data with an empty box in it. To start with, it's a straightforward recall question. 1, state the unit for current. But the second part is calculate the missing value of energy for the voltage of 4 volts. Give your answer to 2 significant figures. I'll just stop for a moment and answer the question. Do we have a summary that describes how each command word is different from the other? Yes. It's in the specification. There's a page in the specification which outlines which command words are used and their definitions. But you can also either download or order directly from the Pearson website posters which do that, which are for displaying in laboratories. And they're great. I've seen many good examples of teachers who've put the command words around the classroom. I have to say to you, but before very long, if you don't do anything with them, it just becomes like wallpaper and students stop noticing them. And I think the real answer is that we as teachers have to keep using those command words in our own language. So when we're asking questions, we have to use the command words accurately and gently challenge them when students misunderstand. So if we ask a question which says, can anybody explain why this is happening? If a student gives you back an answer which is really a describe answer, say, okay, thank you, that's part of the answer, but what I asked was explain. And explain means so that students get used to using the command words in the way in which they're intended to be used. So they get used to recognizing them. There are a number of command words, and some are lower order, and some are much higher order, like evaluate and analyze and so on. But this distinction between describe and explain is so key because it appears in so many questions. And if students always interpret explain questions as describe ones, they're always going to miss one of the 2 marks, and it's throwing away a lot of marks, not because they didn't know the physics, but because they didn't answer the question that was asked. So yeah, the posters, I really recommend them. Strongly recommend that you download them and use them. And as I say, regularly refer to them and use the questions in your own Q&A in lessons. Sorry, back to the calculation question. Calculate the missing value of energy for the volume. So you're filling in the missing blank in the energy column. Just a note about the significant figures. If in this specification, if the question says give it to 2 significant figures or some number of significant figures, that means that's going to be a marking point. So where it says 2 marks available for that second part of the question, one of those marks will be for giving the answer to 2 significant figures. And if they haven't done so, they can't possibly get that second mark. On the other hand, even if they got the wrong answer, if they've given it to 2 significant figures, they can get that second mark. So even an incorrect answer, if it's correctly stated to 2 significant figures, can get the second of those 2 marks. So do spend some time saying to, encouraging students to check out exactly what the question says. I always say to students, when you've done calculations, when you've done a question, have a quick glance back at the question and say to yourself, have I answered all of the question? Because it's really easy to get into the calculation, get the answer down, breathe a sigh of relief and move on and forget that little throwaway line at the end, give your answer to 2 significant figures. Students just glance back at the question, say, oh yeah, I need to round that or put that to 2 significant figures. Just a reminder that students sometimes confuse the term significant figures with number of figures after the decimal point. And as you know, they're not quite the same thing. So do encourage students to know the difference and to use that. Okay, the extended open response or the EOR questions. Here's an example of an extended open response part of a question from paper 1. As you can see, this one is worthy of 4 marks, which is why there are quite a lot of dotted lines there for the student to put their answer on. In fact, there are quite a few more lines provided in the actual paper than are shown here on this page for the response. I've just shrunk some of them out to get the writing visible on the screen. These questions, the EOR questions, tend to come towards the end of the paper, but it doesn't mean that they're the hardest question on the paper. They might be the hardest to mark, I have to admit. Please encourage your students to attempt them, even if they're not confident of getting full marks. It's not actually very common for students who attempt such a question to achieve 0 marks because the difficulty of the parts of the question are graded within the question. So it's actually fairly easy to get the first 1 or 2 marks and a bit more challenging to get marks 3 and 4. So please do encourage students to tackle them, even if they're not sure they can get to the very end. Sometimes students look at it, look at all the blank page there, throw up their hands in horror and think that's not for me, that's for somebody brighter than me, and move on. Please encourage them to tackle them. Because as I say, it's rare for them to get 0, even if they don't get all the way through. What are mark schemes and examiner reports? Here's a sort of screenshot of a mark scheme and examiner's report for one of the November 2023 papers. Have a look what's inside them. What's in the mark schemes? As you'd expect, they're the answers to the questions. They often also give a number of alternative answers that students might give and might be credited for. They may also advise the marker of common errors and what you can reward with marks and what you cannot reward. And examiners are encouraged to use the mark scheme positively, and I'll explain what I mean by that, to look to reward marks for what is there rather than penalise students for what isn't. Just like the misunderstanding that I mentioned of students with multiple choice papers earlier, sometimes we as teachers tend to think if a student's made any mistake, we're going to knock marks off for that, oh, they can't possibly get full marks unless the answer is perfect. That's not the case. That's not the way that examiners work. They're encouraged to use the mark scheme positively and to try and reward marks for what is there. So you're not penalising errors, but looking to build up positive marks. And the upshot of that is that students can get full marks in a question, even if there are errors in their answer. As long as it meets the criteria for full marks in the mark scheme, they can get full marks. So here's an example. It's a screenshot from a section of a mark scheme for paper 1. It's just to illustrate the type of information that's within the mark scheme. So as you can see, the question number in the left-hand column, in the second column, the answer one, the type of answer that's required for marking point 1, that's MP1, and marking point 2, and so on are indicated. And then in the notes column, some acceptable alternatives are shown and further clarification. So you can see for marking point 2, use of plotting compass to show direction, but you can also allow if compass seen in a diagram pointing in a suitable direction. So alternative ways of putting the same information in. So the mark scheme tries to indicate to the marker or to us as teachers, if we're using it in our own work, how we can apply that mark scheme fairly. And then the right-hand column shows the total marks available. And so even if there are more than 3 marking points, the students can't build up more than a total of 3. That gives the maximum mark that students can get for that part of that question. And it goes on. This is the second part of the mark scheme for the same question, to illustrate that diagrams are included where they might help the marker. And as before, there are explanatory notes in column 3. Make that a bit bigger so I can see it. Okay. And you can also see, as I say, the diagrams included there, because often, as we know, a picture can paint 1,000 words, and students can put a significant amount of an explanation or a description of an experiment with a well-labeled good diagram. And this is one of those cases where it can actually be quite a decent answer to a question. And you can see in the notes part, it gives additional information about what marks they can get. 2 marks maximum if any of the lines overlap, but you're allowed to let the lines touch. So that says what you can give marks for, what you can't. It's worth us spending just a few minutes looking at the general marking guidance, because it addresses some common misconceptions which can arise when teachers have not themselves been exam markers. In particular, I want to draw attention to some of the phrases which emphasise that, as I mentioned before, where possible, the aim is to credit good work rather than to punish errors. Have I got a... No, sorry, I thought there were going to be some arrows appearing there. It's worth saying that when teachers engage in marking or moderation exercises, marking blind student attempts at exam questions and then comparing their marks with those awarded by the real examiner, then we as teachers almost invariably mark more harshly than examiners. It's also worth adding that if you do a similar exercise with students, they are often the harshest markers of all. There's sometimes a tendency with both teachers and students to knock off marks for errors. And as I said, that's not the system followed by examiners. So have a look at this general marking guidance. The reason I'm highlighting it now is that when we get into using mark schemes as teachers, this is the page we often skip over, getting into the sort of marks for individual questions. It's a bit like when you give students an exam paper. Although there's important information, the rubric on the front, they're keen to get into the questions. They often skip over that, and there's important information there which can hamper them later on. It's the same with us as teachers. We make exactly the same error and fail to read this general marking guidance. Some of them are obvious. All candidates must receive the same treatment. Examiners must mark the first candidate in exactly the same way as they mark the last. I have to confess, when I'm marking my own students' work, I try not to know whose work it is until I've done the marking, because if you look at the name of the student before you start marking the question, you start second guessing them. They put an answer which is a little bit ambiguous and you think, oh, I know that student, she's quite bright, I know she knew what she was talking about, so I'll give her the mark, I'll give her the benefit of the doubt. Whereas another student, you might think, I think he's just hit a lucky streak there, I don't think he really understood that. And so you tend to mark with the student in your mind. I think it's helpful to mark them blind, not know the student's name until you're totting the marks up at the end. Mark schemes should be applied positively. Candidates must be rewarded for what they have shown they can do rather than penalised for omissions. They should mark according to the mark scheme, not according to their perception of where the grade boundaries may lie. This is what I mentioned earlier. There's no ceiling on achievement. All marks on the mark scheme should be used appropriately. All of the marks are designed to be awarded. Examiners should always award full marks if deserved. If the answer matches the mark scheme, even if there are errors in there, they can get full marks. Where some judgment is required, mark schemes will provide the principles by which marks will be awarded, and exemplification may be limited. Here's an important one, and I think it's worth making sure that your students know this. Crossed out work should be marked unless the candidate has replaced it with an alternative response. Sometimes students, do a calculation and then think, oh, I've got that all back to front. Scribble it out, try again. If they scribble it out so it can't be read, they can't get any marks for it. If they happen to get it right the first time and then incorrectly think it was wrong and do it, they can still be awarded marks for work which has been crossed out as long as it can still be read and if it hasn't been contradicted by a subsequent part. So do encourage your students, if they're going to cross out work, just put a line through it. Don't scribble it completely out so it can't be read. They might pick up marks for the bit they thought was wrong and wasn't. So, if you were here for module 1 yesterday, you looked at this example question. We've seen this one before, the two girls, one of them swinging a buzz around her waist, to discuss which specification points were being assessed. In this module, I'm going to ask you to decide which assessment objectives are being targeted by this question. So same question, but we decided yesterday it was to do with module 3 on waves, on module 8 on space, astronomy. But this time I'm asking you which assessment objectives are being targeted. I've reproduced the assessment objectives there, so you don't have to go scribbling around through your specification to remind you of what they are. So here's a description of the 3 assessment objectives. Do you think the question is asking assessment objective 1, assessment objective 2, or assessment objective 3? You don't have to feed back on this one. You can if you want to in the meeting chat. There aren't that many of us on the line, but I'm just suggesting you consider the answer for it for yourself for a few moments. And after a few minutes, I'll give you the answer. The answer could be assessment of one assessment objective or 2 of them. Examiners are instructed not to try and assess all 3 assessment objectives on one question, so it could only be one assessment objective or 2 of them. And okay, Yan Yang has said assessment objective 1 and 2. Prashant Kumar, assessment objective 2. And I'll leap into the chase. The answer is assessment objective 2. It's aimed at application of knowledge and understanding. Assessment objective 2. According to examiner reports, which come out after each exam series, students tend to struggle with questions such as this one, which test knowledge and understanding in a different context from that in which they probably learned it. I know I said that exact sentence yesterday. I make no apologies for it because it's such an important point. Students tend to struggle with questions which test knowledge and understanding in a different context from that in which they learned it. And there are implications for teaching and learning, which is why I'm going to ask you the question, which is on the next slide. Okay. How can we encourage students to develop confidence in tackling questions like this one, where the context is different from that in which the concept was initially learned? Sorry, just a question. Can you please explain briefly what's the difference between assessment objective 1 and 2? Assessment objective 1 is in effect content, remembering the content, so it's recall. Assessment objective 2 is applying that understanding, so it's understanding and knowledge and applying it to different situations. So assessment objective 1 might be something like restate Newton's second law. You just have to remember it, write it down, simply memory thing. Application assessment objective 2 is where they're being asked to apply it to a real situation. So how would you apply Newton's second law to this situation, or you might have to do a calculation. Okay, so the assessment objective 2 is application of the knowledge. Assessment objective 1 is simply remembering it. Okay, so the question I'm asking you, how can we encourage students not to tackle this particular question, but to develop confidence in tackling questions like this one, where the context is different from that in which the concept was initially learned? You will have taught, or by the time you finish this part, the topic of the specification, you will have taught students about the Doppler effect, about the way in which sound coming towards, sound waves coming towards the hearer to different pitch, a higher frequency than sound waves moving away. And you might have discussed it in the context of racing cars going past, you know, the change in tone as it goes towards you and comes away, or ambulances or fire engines or ice cream carts, anything playing music where the pitch changes as it goes from coming towards you and going away. So students will have some understanding of the Doppler effect, but they've almost certainly not done this situation where somebody swings a buzzer around their waist, because it's actually quite difficult to do in practice. If you think about it, you've got to power the buzzer. So they won't necessarily have seen it in this context. How do we encourage students to develop confidence in tackling questions like this, where the context is different from that in which they learn the concept? I'll stay quiet for a few moments whilst people put suggestions and answers to that in the chat, please. Not seeing any answers yet. Perhaps people are thinking and typing hard. Any thoughts? Okay, there we go. Thank you. By using daily life examples during the lectures, absolutely. Spot on. Any other thoughts? Relating the keywords to daily life understanding? Yeah. It's regularly referring students to how does this learning apply to other situations? Absolutely spot on. It will be impossible for us as teachers to second guess the examiner, the exam setter, and to teach in advance every possible different context which examiners might come up with to ask questions. You couldn't possibly. There must be thousands of different situations for some ideas that they could apply. You can't guess all of them. The key is in developing confidence in students that they've learned the scientific knowledge and understanding and that they have the ability to then apply that to understanding other similar situations where the same scientific ideas and principles apply. There's a good example a few years ago, 2 or 3 years ago, an exam board. I'm not meant to refer to other exam boards, so I shall just say an exam board which shall remain nameless, but it wasn't a fault, it's what happened. They asked a question at GCSE which was about osmosis in one of the balanced science papers, and I can almost guarantee that every student, or 99% of the students sitting the paper, will have done the osmosis question that they were referring to, or the experiment where they cut potatoes into chip-shaped pieces and measured their length, and then sat them in different concentrations of sugary water or salty water, and then measured them again because the osmosis had moved water in or out of the cells and it changed the size of it. And almost everybody will have done that. I think it was one of the core practicals in the biology unit, using potato chips. The question in the exam paper asked a question based exactly on that principle, but it mentioned carrots instead of potatoes. And you'd be astonished, or perhaps you wouldn't, you know, students, how many students metaphorically or literally threw up their hands in horror and said, I haven't learned about carrots, I've only done potatoes. And they didn't realize that the thing they had learned was a general rule which could be applied to other root vegetables as well. You can't possibly do the experiment with every root vegetable that's available, but students hadn't picked up the fact that because they learned it in one situation, it could be applied to many other similar situations. The question on the screen is a good example that's embedded in the specification, as we mentioned yesterday. The same concept comes up in topic 3 waves, and again in topic 8 astrophysics, but in very different context. In waves, we're talking largely about sound waves, you know, going at a few hundred meters per second. In astrophysics, we're talking about redshift, you know, in light waves moving at much, much higher speeds, but the principle of the Doppler effect is exactly the same. And we develop confidence, exactly as colleagues have just said in the chat room. We develop that confidence by regularly asking and discussing such other context questions, and also perhaps by reading around the subject and discussing science-related items from the news or other sources like science magazines, where we can apply our scientific understanding learned in one situation to other real-world situations. So the students start to realize they're not just learning a set of facts which are only applicable in the situation they learned them, but rather some understanding which allows them to develop scientific literacy, so they can apply that literacy to new situations, things they hadn't heard of. They can see items on the news and apply their scientific knowledge and understanding to understanding situations that are new to them and new to other people. And that's the power, of course, of science, isn't it? They're learning general principles which can be applied in a whole range of different issues. Sultan Amina said, we're facing the same problem at our school. I'd love to hear a solution for this. It's not a catch-all answer, but I worked with a number of schools in East London where we were trying to develop something for this. And we looked at developing a sort of regular chat room. In some schools, they were doing it as an online blog. In some schools, they were doing it as a straightforward notice board, a literal notice board. But what they were doing was having a discussion on a scientific topic each week. And to start with, the teacher would suggest the topic, here's a scientific situation, and the bare minimum for all the students was that they were to make one comment on that situation. So they were trying to apply what they understood about what had happened. It might be, the article might have come from the news, and it might be about a space, you know, a space module landing on the moon, or it might have been about tsunami, or, you know, how volcanoes were working. It could be any sort of scientific situation, but students were being asked to comment on the story and add something of their understanding. And it was just getting them into the hang of discussing scientific news using their knowledge and understanding. But what it was doing all the time was getting them to apply to this application of knowledge and understanding to different situations. And it really helped in building confidence. It was just a simple 5-minute thing each week. Once it had got up and running, the teacher was able to delegate choosing the next topic to students. So students would come in and say, can this news item be next week's discussion subject? And as I said, the bare minimum was that students had to make one comment on it, but sometimes they would say more and more, and it just became a discussion item, which kind of outside of the lesson, but fed into the lesson content, because it was just students either contributing to the blog or sticking notices on the notice board. So they were taking part in a scientific discussion, using their growing scientific understanding to understand real life situations. But it really helped in developing that confidence that they can apply. Can I elaborate? I'm not sure I can elaborate more than that, really. The school I was working most closely with at that stage were trying to, we're starting, so yeah, there we go. Always keep the topic inquisitive to relate it to daily life. Today in density topic, I did experiment after to calculate the density of an irregular object. After experiment, I recalled the basic definition and asked them to tell swimming, when would you drown, when would you float, or example of a hot air balloon. Absolutely. I mean, as I say, regular stories that come up in the news or in scientific magazines will be things about climate change, about natural disasters, about flooding, you know, and in the situation I was talking about, students were being asked to say, why is this happening, or what could be done to stop this, and to make comments using their own understanding of what it was that was causing that and how they could apply their scientific knowledge to explain it, or to explain what the situation was. I can't remember the exact example that worked really well, but several examples came up, and they found it. I think we were talking about it at a time when there was a particular space probe. I think it was when they were trying to land this module on an asteroid, and people were talking about what the problems were with that, and students were applying their understanding of what the problems were and how they might be overcome. But it was really, the subtext was that students were being asked to apply their knowledge and understanding to real life situations, to different situations. So I don't think I've explained that really well, but as I say, it built itself. It was getting students to read outside of the specification and to try and use their growing knowledge and understanding to understand other situations, to apply it to different contexts. A really useful resource for teachers and departments and for use with students are the exemplars. This slide just shows the cover of one such. They're downloadable in PDF format. You can download them from the GCSE Physics website, Pearson Edexcel specification one. And it has marked examples of real students' attempts at the sample assessment materials. Or, you know, it has other ones for the various live sessions of exams, such as a snapshot shown on the right of this slide. So you can see on the right hand of the slide, that's a snapshot of the content in this particular book of exemplars. This example is not really for us to discuss in detail at the moment. That's going to come in a moment, but just to illustrate the type of information that's included. And these sets of exemplars are produced after each live exam series, along with the examiner's reports. After each series of exams, the exemplars are produced with examples of students' real answers at the questions, some good, some not so good, and how the mark schemes were applied. As you can see from this snapshot, the exemplars include one or more examples of students' attempts at a question, with the examiner's mark awarded and commentary on why that mark was justified. They're really, really good for getting inside the mind of the examiner, for distinguishing the features which make a good answer, and for learning how to interpret the mark scheme. Let's use one for an activity now. Here's an example. It's an extract from one of the exemplar materials. I'd invite you to look at the part question that I've shown here and the answer mark scheme at the foot of the slide. Okay, so here's one from the exemplars document. It's a part question requiring the plotting of a bar chart from data which is supplied in the question and the mark scheme below. So you can see the question, part question, the student's results are given in the table. So the table shows number of metal discs and minimum current. And in the mark scheme, 1 mark's available for showing the scale on the y-axis, 1 mark for both axes labelled with variable and unit, 1 mark scheme for how it's plotted, sorry, 1 mark point for how it's plotted and 1 mark point for the bars drawn. That's to plot a bar chart. So total possible marks 4. I'm going to ask you to use this to award marks for 2 examples. So here we are. There are 2 examples of student attempts from the exemplar document, and the examiner's marks and the comments have been blanked out, so you can just see the students' questions and answers here. I'm going to give you a few minutes to decide what mark you would award for each of these. So the one on the left and then the one on the right, 2 separate attempts. I've reproduced the mark scheme again, so we don't have to keep flicking back to the previous slide. So I'm going to give you a few minutes and say, what mark would you give to these 2 attempts using this mark scheme? When you put your answer in, I would suggest that you put the mark for the left-hand one first, and then the mark for the right-hand one second. So if you think the left-hand one is worthy of 0 marks and the right-hand one for 4 marks, you'd put 0, 4 as your answer. So we know that your first mark refers to the left-hand one, your second mark to the right-hand one. I'm going to shut up for a moment to give you a chance to mark them and put your marks into the chat, please. And when a number of people have put their marks in, we'll have a look at what the examiner said. Okay, Jinjin, you've put 1 mark, but I'm not sure whether that's the left-hand one or the right-hand one. Remember, there are 2 answers here, so I need 2 marks really, 1 for the left-hand one and 1 for the right-hand one. Okay, 3 for the left-hand one, Junaid is coming in with, and 1 for the right-hand. Okay, we've got a starting point. I'll leave it open for other people to put in their marks. Okay, Salsamina's come in with 3 and a 2. I won't give you the answers yet until more people have put marks in, and then we'll look at the answers together. Positive front, it stopped raining here, which is good news. 3 and a 1, and another 3 and a 2. So we got 2. Everybody's saying 3 for the left-hand one, but we got alternatives of 1 and 2 for the right-hand one. Okay, interesting. And as you can see already, even with only 4 marks available, you get a range of interpretations. And that's kind of the point, really. So everyone, I think, is saying that the left-hand one is better than the right-hand one, which I would totally agree with. So there's a general consensus in which is the better answer, but the number of marks we would award for the right one is varying between 1 and 2. Any more people suggesting the marks? Well, we've got 24 people on the course. I'm sure we can get more marks in than that. I certainly wouldn't disagree with you, Junaid. The question demands for a bar graph, and the right one is not a bar graph. You're right. Okay, let's have a look at what the examiner said. Here we go. So here I've included the examiner's mark and the comments. The example on the left gained 3 out of 4 marks, so spot on. Everybody who marked that one with got a 3, I think. So yeah, the example on the right got 2 marks as shown. Okay, so the one on the left 3 marks, the one on the right 2 marks. It's absolutely it's worth acknowledging that some of you have marked these differently, and as I said, there's a small range of marks, but let's have a look at why. Remember, the purpose of it, the purpose of this exercise, I mean, is not to challenge the mark or the question, but to understand how the exemplar can help us to get teachers to be able to apply the mark scheme fairly. In other words, to use it as examiners. Let's go see their explanation as they go on. Here we go. Here is the explanation, the fuller explanation in the exemplar itself. Question is designed to test assessment objective 3, which is about experimental skills, analysis and evaluation of data and methods in physics, which is 20% of the marks available. It's set in the context of an electromagnet, and question mixes content and skills. Almost 25% of students could not name the independent variable in question 6A1. It just needs practice. The variable that you choose to vary is the independent variable. The one that you have to alter or measure as a result is the dependent variable. In question 6A2, almost half of the students got it wrong, with the most common confusion being that iron conducts electricity. Okay, so they're all about the first part of the question, which we weren't looking at. The relevant bit to the one we've just been looking at, the last sentence, many students made simple errors when drawing the bar chart. As we correctly pointed out, let's just flick back to it for a moment. The one on the right isn't a bar chart. Okay, why does it get 2 marks? Let's have a look. The mark scheme said 1 mark for the scale on the y-axis. So it's gained 1 mark for the scale on the y-axis. Both axes labeled with variable and unit. Not right. Plotted. It's plotted. Even though it's not being plotted as bars, it's being plotted. They've correctly plotted the points. So they got 1 mark for the scale and 1 mark for plotting, even though it's an incorrect plotting. What they haven't got is axes labeled with variable and unit. There's no label on the bottom one, and the bars not drawn because they haven't done a bar graph. Okay, so it's gained 2 of the marks. Remember, we're awarding them positively, so they've plotted it. Even though they haven't plotted bars, they've plotted the points correctly, and they've correctly put a scale on the y-axis. The error which makes the left-hand one 3 marks is that the bottom axis isn't uniform, is it? 0, 2, 5, 6. You know, it goes up in irregular lumps. Okay, and also they haven't labeled it. But yeah, but as I say, it's a bit like, I don't know whether you're keen on watching football, but in the UK Premier League recently, we've had a thing called VAR, Video Assistant Ref, where somebody is sitting watching the video, and if a referee makes a decision on a penalty or something, it goes instantly to VAR, and the video assistant ref looks back at the replay of the video and says, no, that wasn't a penalty, or he was offside, or whatever, you know. And we spend ages those of us who waste our time watching football matches on TV, arguing with the video ref and saying, no, that's not a penalty, or he didn't touch him, and all this sort of thing. But the point, of course, is not whether we agree with it or not, although that's great fun, and you know, spend lots of Saturday evenings doing exactly that. The point is, it gets us inside the mind of the referee, because the person doing the VAR is also a referee with the benefit of hindsight. They can keep looking at the re-recording, and what it does, the more we hear the VAR discussion, is it gets us inside of, okay, we might not agree with it, but this is how the referee is interpreting the rule book to give or not give the penalty or the goal or whatever the decision is. And that's exactly what these exemplars do. The more we look through them, the more it gets us inside the mind of the examiner and say, okay, we might agree with it, we might disagree with it, but this is how the exam board, how the examiners are interpreting the mark scheme. And it's really useful information for us as teachers and for our students. So a really useful activity to do, I think, with these is what you and I have just done, which is in department meetings. It's really good use of time for training the whole department. Get someone to photocopy examples of questions with 2 or 3 examples, give the mark scheme, but leave out the commentary, what marks were awarded, and get people to mark them blind, as you have just done, and then look at the examiner's marks, so we can compare what marks we would give and then what the examiner has done, and it gets us closer to and the discussions that take part are really important of how and why the mark scheme has been interpreted in that way and applied in that way. It's also a really useful exercise to do with students, get students to do the same thing. And as I say, don't be surprised if you find that when you do that, students are particularly harsh markers, but it gets students, the ones who are doing the marking, get a real insight into what makes an answer a good answer, what's not such a good answer. It gets students inside the mind of the examiner, how the mark scheme is being applied. Really useful example. I would say that the x-axis is not only numbered in an irregular manner, but also it's not labelled correctly with the unit in the first place. And I would absolutely agree with you, but you can only lose that mark once. So the fact that the student has lost the mark for the axis label, they can only lose that once. So you don't take off a second mark. They've lost that mark and they've completely thrown it in the sea, but they've only lost it once. What you don't do is keep penalising them for more and more errors. Yeah, thank you. Thank you for doing that. Let's move back to looking at what we're going on to next. Here's an example of an extended open response question, or part question, based on the astrophysics topic. And on the next slide, I'm going to show you the mark scheme. So it's one of those Hertzsprung-Russell diagrams, which shows how different astronomical objects may be classified according to their colour and absolute magnitude. If you haven't taught an astrophysics or astronomy topic before, this might look completely unfamiliar to you, but it's part of the specification. Okay, and here's a question within that. The Hertzsprung-Russell diagram shows absolute magnitude against colour for stars in different stages of their evolution, stars similar mass to the sun. And the question says, describe the evolution of stars of similar mass to the sun. So describe is the command word, of course. So they're being asked to say what is, describe in steps the evolution of stars. You should refer to the temperature and brightness of the stars in your answer. Just a clue, when an examiner says something like that, you should refer to, that means if you don't refer to that, you're not going to get that mark. Okay, so you should refer to is an absolute instruction. It's not a hint or a suggestion that you might like to consider. It means you should refer to that or you're not going to get the marks. It's a straightforward hint. If we look at the mark scheme for it, you can see there's a whole bunch, 10 marking points. So although the maximum number of marks is 6 on the right-hand side, they can pick up that 6 by getting any 6 of those marking points, the whole list of possible answers there, with some notes suggesting that alternatives. So instead of saying the nebula collapse, they can say contracts. Instead of saying that the brightness or the temperature of a main sequence star depends on its mass, they can also allow the word size. So it gives different alternative wordings. Just as a pointer, I didn't check when we came in whether any of you are working in international schools in the UK, but if you are, if you are in a centre where you're offering some international GCSEs and some UK GCSEs, I should say there's a significant difference between the mark schemes for the international GCSE and the different level-based mark schemes for similar questions in the UK GCSE. If you're all logging in from overseas locations, that's probably not a problem because you're probably all doing this in just this international specification. But as I say, if you're in a school where it's offering both routes, UK and international, you need to know that these marking schemes for the EOR questions are significantly different between those two. Okay, so it's just worth mentioning that there is a difference there. Does this mean that you're not asking too much? I absolutely approve of you asking questions. Does this mean that the student cannot say the nebula is compressed? No, I think that would be allowed. The fact that an alternative isn't in the notes doesn't mean you can't, unless it specifically says you can't allow this. So it does say in the general rubric on the mark schemes, students can explain the same information using different words as long as their meaning is clear. Yeah, okay. And in your question, the UK one is more strict. You're absolutely right. Yes, it is true. The marking schemes for the UK specifications is more strict. The international GCSE is a bit more flexible in which answers are allowed. Yeah, that's true. And yeah, that's right. Okay. This is the feedback in the examiner's report on the question we just looked at, the Hertzsprung-Russell diagram one, identifying which parts were generally done well and which parts not so much. So question 4 discriminated well between candidates, and this new area of the specification had clearly been well learned by most candidates. Most responses communicated the correct stages in the evolution of stars of similar mass to the sun and also in the correct order. Those candidates who commented on the changes in temperature and brightness often gained marks for describing the correct changes in temperature, but gave incorrect statements about the brightness. Candidates were expected to interpret this information from the absolute magnitude scale of the HR diagram, and many candidates incorrectly assumed that a more negative absolute magnitude corresponded to a dimmer star. The best candidates produced well-structured responses that presented all the evolutionary stages in the correct order, whilst commenting on the changes in temperature and brightness between each stage. Now, you might at some stage think this comes under the category of too much information, but actually it's really, really useful. If your students have just tackled a paper and you're looking at how they did and which ones did well and which ones not so well, when you're looking at, you've got access to their script, so you've seen how your students do, it's really useful to see why the students who did well did so well and which ones didn't do so well, and compare that with how other students do, because it's not going to help the students who just finished their exam and got their mark, but it's absolutely going to help the students you're teaching in the next cohort. So really, really important feedback on how we can improve our teaching and learning each year to make sure our students tackle the problems which students have previously had on them. Keith, is it better to encourage students to give maximum knowledge as no negative marking, so they give maximum information relative to understand? I would certainly encourage them to put in as much detail as they're able to, but not to flannel it, and also be aware of the danger of putting too many alternatives. You can't, for example, you can't put two alternative answers which contradict one another and say one of them is right. That's not accepted. If students put two answers where one contradicts the other, they won't get the mark for it. Okay, but it is worth students putting in as much detail as they think they need to. I think students sometimes, particularly brighter students, often leave out part of an answer because they think it's obvious. Well, it might be obvious, but it's not obvious to the marker that that student knew that. So, yeah. Will alternatives cause even the right one to be marked wrong? If it literally contradicts it, then yes. So, in a simple situation, if the question says, is this up or down? And the student puts, it is up and down, they will not get the answer, even though the right answer is in there, because they've done the things which literally contradict them. They won't get that mark. So yeah. Okay. And it said that, didn't it, within one of the marking schemes we were looking at earlier, where I said if something's crossed out, they can still get the mark for it unless their subsequent answer has contradicted it. Okay. Okay, thank you for that. It can be a really, really useful exercise. Assessment of practical work. This booklet, the International GCSE Core Practical Guide, Biology, Chemistry and Physics, is downloadable free from the Pearson website, and I strongly recommend that you do download it when you're going to use it. As mentioned earlier, all of the assessment of practical work is in the written exams. It's about 20% of the total marks. There's no practical exam or assessed practicals in this course. And this increases the need over what might have been the case in older specifications, increases the need for learning during practical lessons to be planned carefully so that students develop the skills necessary to tackle those exam questions. The Core Practical Guide is an invaluable tool to aid this area of learning. If you haven't already downloaded it, strongly recommend that you do when we finish. Here's an outline of what's included in each chapter of the Core Practical Guide. So for each of the core practicals, it includes links to the relevant specification content. introducing the practical, so some guidance on how to carry out the experiment, questions you could ask to enhance learning, skills that are covered in the practical, math skills, one or more exam questions related to the core practical with mark scheme and examiner comments. Let's have a look at an example of one of these. Each core practical links to a specific point or points within the content. I'll be showing a link to the website later on in the session, Sultan, if that's okay. So I'll show you where the website is in a little while. Each core practical links to a specific point or points within the content. It's advised that the core practical and other practical activities are taught when they arise within the teaching, not separated from that delivery in special practical lessons. As I said yesterday, just because that's when we have a double lesson or whatever. They're effective ways of delivering the content, and both content and applications in different contexts are much more likely to be learned when they're taught together. So you can see in this example, it gives the links to the parts of the specification that this core practical on investigating the frequency of a sound wave using an oscilloscope, these are the points which it's linking to. As you can see, they're all physics only ones, you know, they're in bold with a capital P. Here's the core practical, so quite a bit of information about doing it. So one or more ways of carrying out the experiment is outlined, and further information, including alternative practicals and other approaches, can be found by following the hyperlink. So when you download it digitally, you can see at the bottom where it says further experiment on this experiment, further information on this experiment, and there's a hyperlink on the word here, will click you and give you other alternative ways of carrying out the same practical with different sets of equipment. The questions to enhance learning are a really valuable part of the core practical guide. I strongly advise that they're not all set as written or homework questions, that's just indigestible, but rather used in class when you're setting up the practical to get students to think more deeply, higher order questioning. Students need to think not just what are we doing and what equipment am I using, but why this piece of apparatus? Why this technique as opposed to alternative methods? Questions that are asked in the exam will include challenging students to apply their knowledge and understanding gained in the context of one experiment to investigate a practical situation in a different context. And examiners' reports tell us that students find these questions particularly challenging. We need to be preparing them for this by promoting a deeper understanding of apparatus, techniques and analysis when they're doing the practicals. The section skills that are covered in the practical identifies the transferable skills and techniques which students may be required to apply to different contexts in an exam. So you can see there are a few questions to enhance learning on this page. Can you demonstrate that the sound of source is still emitting even though you cannot hear it, and so on. And then skills that are covered in the practical: use of an oscilloscope, use of a SIG-gen and loudspeaker to produce a sound, appreciation of orders of magnitude. And finally, after the questions to enhance learning, there's an example also in the core practical guide of one or more exam questions which are linked to that core practical. So having done the core practical, here are examples of exam questions where this is tested. So students, having done the core practical, can have a go at a question which tests exactly the knowledge from that practical. This is the way it might be examined in a real exam. And the mark scheme for the example question is also shown to show what type of answer gains marks. And it also has, in the box at the bottom there, examiners' comments on how this question was tackled when it was last set and common errors or misunderstanding. So quite a lot of relevant types of information for each core practical in the core practical guide. I strongly recommend downloading it in digital form rather than just printing it off, because it keeps being updated. People add more and more questions. As more questions are asked each year, the core practical guide gets bigger and bigger because it keeps having more information added to it. So it's worth keeping in digital format and updating from time to time to see the most relevant up-to-date information on those particular practicals and other ideas of some schools have found this really useful or other ways of working it. So it's a working document. A question: What are the implications of the way in which practical skills or working scientifically skills are assessed for teaching and learning? What are the implications for teaching and learning, especially when we're doing core practicals or other practical activities? To put it another way, how do we best prepare students to be able to tackle the ways in which questions about working scientifically are asked? Any suggestions? I'll give a few moments for any ideas to go into the chat room. What are the implications for how we teach practical skills? I won't get very long for this because time is cracking on now. I'm sure you have other things to go on to do as well. Wow, where have you cut and paste that from, Junaid? Thank you. That's good. That's good information. Yeah, and a good idea. I think typically as teachers, we've often underplayed the importance of experimental activities, and they've almost been an add-on or a way of sort of adding to what we were, the real business of teaching. But in this specification and others now, it's such a vital part. What's the word I'm looking for? Yeah, it's a crucial part of the specification itself, part of the learning. And I think in addition to doing the practicals, we have to be thinking, what are students learning? How am I tracking that students are learning the skills in the practicals, the core practicals and other practicals? How am I checking that they're learning what they will need to be able to tackle the way in which questions are asked? So I think, as I said yesterday, it's moving the focus away from what are students doing in an experiment towards what are students learning. And that's been a change, I think, in our philosophy of how we use experiments in science. It's good scientific practice. I mean, I think the real implication, as I say, is exactly that. It's thinking, what are students learning? What is it they need to learn? What are the transferable skills, both for this specific area of the physics topic that's been tackled in this core practical, but also core skills and transferable skills and general practical and experimental skills, things like plotting graphs, recording data, reducing errors, improving accuracy, improving precision, all these sorts of things. Identifying and controlling variables so that we're only varying one thing at once, making accurate measurements. So all those skills, selecting the correct apparatus, they're all skills that I think we need to be I'm not making everything into a tick list, but I think we have to, just as we assess how students are learning in the theory, and we test them with things like past paper questions and check that students are understanding what they've just learned. I think we need to do that within experimental activities as well. Check their learning, record what students have learned, and assess, check that students are able to tackle questions which are based on those. And you're absolutely right. Without practicals, a student's interest in the subject is likely to die out. Yeah, totally. I agree with that. I mean, I know we're not children's entertainers, but we've got such a powerful tool in physics, I think, because experimental hands-on activities are such a good motivational tool. Why wouldn't we use it? Students love it. You know, if you ask students what they enjoyed about their science lessons, they're the bits which typically they really do enjoy. And although, as I say, we're not children's entertainers, if students are motivated, that's the hardest part of our job as teachers done, I think, because they then want to learn, they want to find out. So that really is the hard part of the job. It's the whole business of, you know, you can lead a horse to water, but you can't make it drink. By motivating students, you're making them thirsty. They want to know the next part. So it's such an important part of our job. So yeah, and I think that practical is a really key element of doing that. So the more we can introduce it, even small practical activities, little, you know, 10-minute mini practicals and so on, it all helps to motivate students and to get students to see how what they're learning in theory applies in a real world situation. Okay, thank you very much. I'm going to move on because I'm conscious that time is moving on, and I want to go on to a little section on exam technique. This shows the general rubric that's on the front of one of the physics papers. And just as I mentioned about the mark scheme and us as teachers before, this is the bit that students will often skip over because they're keen to get into the questions itself. So I just want to consider for a few minutes which points we might want to draw students' attention to in preparing for the exam so that we can flag them up beforehand so students know that. Let's identify a few. I'm just going to stick a few arrows on there of points I would want to draw attention to. First one, there may be more space than you need. The key point that students need to ask themselves is, have I answered the question which was asked? Not have I filled the space provided. If you look at exemplars in the examiner's reports, they show that answers achieving full marks are not always longer than those achieving lower scores. Have I answered the question is the real question, not have I filled all the space. Second one, showing all the steps in a calculation is essential. Now, if the final answer is correct in a mathematical question, then the student gains all the marks. But if the answer is incorrect, and in the stress of an exam, it's dead easy to make a simple error, press the wrong button on a calculator or make a silly mistake under pressure. If the answer is incorrect, many of the marks can still be awarded for correct steps, including for steps which were correctly carried out with wrong data from a previous step. It's called errors carried forward, or ECF. So always, always, always encourage students to show their working in a calculation. I'm the kind of teacher who I won't actually mark a student's attempt unless they've actually shown their working. So if I just see a numerical answer, I'm not going to dignify it with a mark. I won't mark it unless they've shown their working. To my sadness, the exam board aren't as harsh as that. You know, if the student has put the right answer, even without working, they will get all the marks. But as I say, if the answer isn't right, they can't get any marks if they haven't shown their working. So always, always, always get students to show their working out. As a very rough rule of thumb, a minute per mark is the guide to the time to be spent on each question. You can say the marks for each question are shown in brackets. Use this as a guide to how much time to spend on each question. Where students often fall foul of this is the multiple choice questions, which tend to be 1 mark, which means they should be doing them in about a minute. They shouldn't be spending too long. And sometimes if students have a choice in the matter, I would always encourage them to do the multiple choice questions at the end, because if they run out of time on them, they're the ones where they will lose the fewest marks. Students who start on them will often spend too much time, particularly conscientious students spend too much time on them and run out of time on the questions which have a lot more marks carried on them. Read each question carefully, absolutely essential. As I mentioned before, students often lose marks by not answering the question that was asked, but writing something else about the topic that's raised in the question. The answer might be correct science, but if it hasn't answered the question, it won't get the marks. The command word is absolutely key to this. So the first part of good exam technique is preparation. What they say, failing to prepare is preparing to fail. Practice is important so students know what to expect and feel comfortable and confident when they see a paper. So not only should they practice past papers, but also incorrect answers should be discussed and students should have another go so they can understand what they did wrong. It can be done as self-assessment or peer assessment using the mark schemes. I'm going to look at one suggested strategy. It's not the only one, but just one strategy that I've found success with, but as I said, other strategies are available. This is what I do with students to help them tackle a paper. So not to learn the physics, but how to tackle a paper. Having a strategy plan builds confidence. Make sure students know how a paper is ramped and that there are easier items at the start of each question. The Edexcel papers always follow the same format, so students can get comfortable with what to expect. They start to see the ways in which questions are asked. Let students know that topics can be in any order, so they might find later questions easier than early ones if they're topics they're more confident in. Let's just look at the strategy. Look through the whole paper first, underlining, or better still highlighting, the command words in each question. Decide which question to do first. Start with the questions you feel most confident with, which is not necessarily question 1. There's absolutely no reason why students have to start with question 1 and go on to question 2 and then 3. If they start with the easier ones, the ones they find easiest first, it builds up confidence, packs a few marks under their belt, and by the time they get onto the harder questions, they're in the flow and they're sort of lost some of their initial exam nerves and more likely to tackle them sensibly. Read the question carefully. Don't repeat the stem of the question in your answer. They don't lose marks for it, but it just fills up space and they don't gain any marks for it. Don't give up on a whole question if you find one section difficult. Move on to the next part. And the same strategy holds for whole questions you find difficult. Move on. Come back to missed questions and parts of questions when you've picked off all the low-hanging fruit. Just give a moment for anyone who's on the call to share any strategies you share with your students that you find effective. Are there any exam strategies that you've found effective that you want to are prepared to share with us now? Leave that open while I go on to the next part for people to share any strategies they find successful. Just want to mention walking, talking mocks, which is a way of doing what we've just talked about. The walking, talking mocks are a number of schools have tried these out. This is how it works. Students sit in the same exam room where they'll do their exam, preferably in the same seats. It can be done in a classroom, but it's not always as effective in building confidence in exam conditions. Students are given an exam paper which is as close to being like the real thing as possible, so they get familiar with how it works in an exam. And then students are literally walked through every question on the paper. So if you're leading the session as a physics teacher, you would have the question on the board at the front, and they can see the question in the paper in front of them, and you would talk them through how you would tackle that question. Here I'm underlining the command word. Okay, I'm making a note of these are important bits of data in there. This is how I would tackle this question. So you literally talk them through your thinking, the smallest steps, underlining keywords, how to plan, things to remember. You might want to focus on a particular area. So it might be mathematical questions or questions based on practical investigations. When you've been through the paper and literally modeled how you would tackle the questions, students then do the paper themselves. So you've just talked them through how you would do it, and then they write their responses in time conditions. Hopefully they do quite well on that one because you've just literally told them how to do it. But it really builds confidence and gets students into good habits of this is how to tackle a question. And teachers have reported really good feedback on how that's developed confidence in students to tackle themselves. There are Pearson videos available online on YouTube, but also on the Pearson website. And there are science examiners and science trainers delivering walking, talking mocks about 10 minutes long. You can use them as a video with students, but they're also a good model of how you might run some walking, talking mocks yourself. Worth having a look at. Janita said, I usually begin with knowledge, definitions, formulas, then go on to understanding-based questions. Gradually move towards exam type past paper questions, topical first, then timed exam questions. Meanwhile, sometimes making them check a solved sample exam. Yeah. To approximate the time level you give the students depending on the number of models. Yeah, absolutely right. Yeah, the number of marks. That's absolutely right. I mean, sometimes you can give students an indefinite time to tackle a question in depth, but certainly as students approach an exam, they need to be having an experience of timed exam situations, so that they get used to the sort of pace they'll need to work in an exam and be able to do that without it being too stressful. Yeah, really useful practice. Okay, we're coming on to a little bit on support and resources. Since I think almost everyone, if not everyone on this course was on module 1 yesterday, I'm not going to go through this in quite as much detail because I don't want to just repeat myself from yesterday, but just a quick flick through to remind you of things that I drew attention to. And if you want to, you can always ask questions about them. Here's a summary of the support that's available at every stage. It's a table I shared yesterday, so you can see them on your copies of the slides as well. And the under the categories of free resources and support, module 3 of this course, which is a later date, will go in more detail in some of the free resources and support that's available on the website. If you want to sign into that, you can find more about those. Mention of the Pearson published resources. As you know, Pearson is a publisher as well as an exam board for Edexcel, and so we publish student books and teacher guides on each of the specifications that are offered. Just a reminder, you don't have to purchase Pearson resources and textbooks to deliver Pearson Edexcel specifications. We believe they're good and they're matched directly to the specification. But if you've had previous experience of a different textbook that you found really successful, there's absolutely no reason why you have to put them in the skip. As long as you check that they're covering the same material at the same depth, you can use them or use parts of them for your teaching. That's absolutely okay. You don't have to buy new sets of textbooks in order to deliver the specification. If you want to look at more detail at what's available and to get samples, the link at the bottom, www.pearson.com, international schools, you can see what's available within the various books. And the paper book also gives students access to the ebook version, where they can access interactive activities as well and tackle those sorts of questions. There's a code within the book which gives them 3 years access to the digital version. Mentioned teaching hubs yesterday. The teaching hubs provide fully comprehensive planning and front of class guidance, so teaching and learning materials along with exam prep resources and continuous professional development support to help you deliver international GCSE lessons, whether you're a specialist or a non-specialist teacher. And as I mentioned yesterday, please do contact your dedicated subject advisor, Irene, who is a goldmine of information. Now, I mentioned the website earlier. I can't live get up to the website on this, but if you type in any combination of the words Pearson or Edexcel and International GCSE, it will take you to the heading page, and then all of the subjects are listed in alphabetical order. So you scroll down to physics and it will give you a page that I shared with you yesterday, where the website then gives you links to exam materials, teaching and learning materials. So you can look up past papers, you can look up the exemplars, you can download and also find access to things like the exam wizard and results plus, and the access to scripts and all those other facilities. So if you go to the heading page for your subject, that's also where you can find a link to Irene. And so it's all a sort of one-stop shop. So to say, you can remember the whole code, which is this qualifications.pearson.com, or you can simply type into a search engine like Google or any other good search engine combination of the words Edexcel and International GCSE. I emphasize the international bit. When you come to the heading page, there's a tab up at the top right hand corner which allows you to toggle between UK and international specifications, and there are differences between them, so make sure if the international is the one that you're looking at, that you toggle onto international, and it will give you the right things for there, and you should be able to gain all the resources there. If there's anything you can't find, ping a quick email to Irene and she will sort you out and tell you where it is, or send you a link directly to it. Okay, I think we've come to the end of the formal content of this session. As before, in a moment, I'm going to give a chance for people to answer questions. I'll stay online for a while to take any follow-up questions. But just before we go on to that, I would invite you to, as I did yesterday, to share in the chat box one thing that we've discussed that you'd like to find out more about or like to do as soon as you return to your classroom or department. Is there anything that's whet your interest this morning that you'd like, or I'm saying this morning, I know some of you are in a time scale where it's not morning anymore. Is there anything we've done during this session that you'd like to do as soon as you return to your classroom or department? And as I say, I will leave it on this page, questions, and stay open. We've got some time, a few minutes left before we run out of time on this event. I can try and take any follow-up questions.